Now we're going to talk about a rule that is needed, especially needed when you have to take the derivative of a function raised to a power. So for this function, you do not need a chain rule, but for this function, you do need a chain rule. See the difference? This function is a function raised to a power. For this function, you don't need a chain rule. For this function, you do need a chain rule because it can be written as a function to a power. For this function, no chain rule is needed. For this function, you do need a chain rule. Okay, now I'm going to confuse you a little bit. Y equal x cubed, you don't need a chain rule. But if you have y equal cosine of x quantity cubed, you're going to need a chain rule. Now, y equals sine x, you don't need a chain rule. But for y equals sine of x quantity cubed, where the argument is cubed, you do need a chain rule. So the last two, y equal cosine x, is where you have a function cubed. So it follows the x cubed model. But y equals sine of x cubed is asking for the sine of an argument that's cubed. So it's going to follow the sine of x model. Actually, it'll be sine of u model. So it'll be easier once we get into the chain rule. Okay, so here's the chain rule. If y is a differentiable function of u, where u is some function of x, then y equals f of g of x is a differentiable function of x. And so basically what we can say is that if you want to find the derivative of y with respect to x, you can take the derivative of y with respect to u and then multiply it by the derivative of u with respect to x. Now there's a couple of ways to write this. One is to think of the function as just a composition function with f composed of g. So if you think of it that way, then the derivative of f composed with g would be the derivative of f evaluated at g times the derivative of g with respect to x. Now, I actually like this one. This is the same thing, but instead of g of x, we're using u to replace g of x. So f of u, the derivative of f of u, is the derivative of f with respect to u times the derivative of u with respect to x. So let me show you how this fits. All right, let's say we have y equals x squared minus 2 raised to the fifth. Well, you can think of this as a function of u. So you can think of it as u to the fifth, where u is x squared minus 2. Okay, well, what's the derivative of y with respect to u? Well, the derivative of y with respect to u would just be 5u to the fourth. Now, what's the derivative of u with respect to x? Well, the derivative of u with respect to x would just be the derivative of x squared minus 2 with respect to x, which is 2x. So now put it all together. The derivative of y with respect to x is the derivative of y with respect to u, which is 5u to the fourth, times the derivative of u with respect to x, which is 2x. But remember, u is actually x squared minus 2, so if we replace u with x squared minus 2, we get 5 times x squared minus 2 to the fourth times 2x. And then you can simplify that by multiplying 5 times 2x together and get 10x times x squared minus 2 to the fourth. Now, there was a lot of moving parts there, but it's really not as difficult as it sounds. So you could look at it this way. This function, x squared minus 2 to the fifth, is actually equal to f of u, where you have u to the fifth. Well, the derivative of this with respect to u would be 5u to the fourth, or 5 times x squared minus 2 to the fourth. And then u is the other function, g of x. So u is x squared minus 2, and u prime is 2x. So basically what you're doing is you're going to take the derivative of u and then multiply it by u prime. Well, here's the derivative of u right here, and then here's u prime. So you're basically going to multiply those two together to get the derivative. Okay, here's another example. Let's say that you wanted to find the derivative of 3x minus 5 to the 1/2. Well, really, that's just u to the 1/2, where u is 3x minus 5. So what's the derivative of u to the 1/2? It's 1/2 u to the negative 1/2. So if we replace u with what it equals, that would be 1 over 2 times the square root of 3x minus 5. But now what's u prime? Well, u prime is just the derivative of this with respect to x, so that's just 3. So now if you multiply these two together, you're going to get 1 over 2 square root of 3x minus 5 times 3, which is going to be the derivative. So that's going to give you the derivative. So hopefully it's kind of settling in with you now. All right, here's u to the 2/5. So we can say u to the 2/5, and then the derivative of u to the 2/5 with respect to u would be 2/5 u to the negative 3/5, which would be 2 over 5 times this, since this is u, to the 3/5. Well, then u is 3x squared minus 5x plus 1, so what's u prime? Well, u prime is simply 6x minus 5. So then you take f prime of u, which is this expression, and multiply it by u prime, which is this expression, and you get this times 6x minus 5, and put it together, and you've got the derivative. Okay, so that's basically powers. In a minute I'm going to show you what's called the general power rule that actually makes this easy to figure out. Now I've got one more power I want to deal with, but this time instead of a polynomial to a power, I have a trig function to a power. So this would be y equals cosine x cubed. So this would be like y equal u cubed, where u is cosine x. So what's the derivative of u cubed? Well, it's 3u squared. Well, since u is cosine x, that's the same as 3 times cosine x quantity squared, which can be written as 3 cosine squared x. Now, but what's u prime? Well, u prime would be the derivative of cosine x, which we know is minus sine x. So now when you put all this together, you have the f prime of u, which is 3 cosine squared x, times u prime, which is minus sine x, and then do a little bit of rearranging, and you get minus 3 sine x cosine squared x. Okay, now this one's not a power rule, so here's how you have to think of this one. This is not sine x quantity cubed, it's actually sine of u. So this is actually sine of u, where u is x cubed. So what's the derivative of sine u? Well, the derivative of sine u would be cosine u. So since u is x cubed, that would be cosine of x cubed. Now, what's the derivative of u with respect to x? Well, since u is x cubed, the derivative of u with respect to x is 3x squared. So now put it all together, multiply f prime of u times u prime, and you get cosine x cubed times 3x squared, which we generally write it with the 3x squared first. So that's 3x squared times the cosine of x cubed, and that's the derivative. Now with powers, you generally can think of this as the derivative of the outside times the derivative of the inside. So if you want to think of it like this, that's fine. So here for this function, this polynomial to the 10th power, I have the outside, which is all of this raised to the 10th power, and the inside is just the polynomial. So the derivative of the outside, I can use the power rule, 10 times that polynomial to the 9th power, and then the derivative of the inside would just be the derivative of this, which would be 12x squared minus 14x plus 2. So basically you're just going to multiply these two together, the derivative of the outside times the derivative of the inside, to get your answer. So you're going to have 10 times this polynomial to the 9th, and then times the derivative of the inside, which is 12x squared minus 14x plus 2. Now, with trig functions, when it doesn't involve a trig function to a power, it works a little bit different. Here, you have secant of x cubed. So the outside is actually secant of the argument, and the inside is actually the argument. So the derivative of the outside, well, you have to say, what's the derivative of secant of an argument? Well, if you go back to the derivatives for trig functions, the derivative of secant u is actually secant u tangent u. So that would be secant x cubed tangent x cubed. But then what's the derivative of this inside? It's 3x squared. So put it all together, multiply the derivative of the outside times the derivative of the inside, you get 3x squared times secant x cubed tangent x cubed. The general power rule is really just a sub-rule that comes under the guise of the chain rule. Basically it says if you want the derivative of a function to a power, it's just n times the function to the n minus 1 times the derivative of the function with respect to x. So example, if you want the derivative of this trinomial to the 7th power, it's just 7 times the trinomial to the 6th power. But then you have to remember to yank the chain, so to speak, multiply by the derivative of the inside. And also that applies to trig functions that are raised to a power. If you want the derivative of tangent of x to the 5th power, that would be 5 times tangent of x to the 4th power. But then you have to multiply by the derivative of tangent x. And the derivative of tangent x is secant squared x. And sometimes it's helpful to think of trig functions written as a power, like tangent to the 5th x, as tangent x quantity to the 5th. So that might help you understand this a little better when you do that. Now let me look at a couple more examples. So if I want the derivative of cosine cubed x, then what I'm going to do is I'm going to apply the general power rule, and I'm going to have 3 times the cosine squared x, and then times the derivative of cosine, and the derivative of cosine is minus sine x. And here I just kind of rearrange it for you. Okay. Now on this one, we're going to have to rewrite this as the trinomial to the 1/2 power, and then you can apply the general power rule. So that would be 1/2 times the trinomial to the negative 1/2 power, and then you multiply by the derivative of the trinomial, which is 2x minus 5. And then here I just rewrite it without the negative exponent. And then this one, again, you're going to have to rewrite it as a power, so I can write that as 2x cubed plus 11 to the negative 4th. And then when I take the derivative, I get negative 4 times this binomial to the negative 5 power. And then I have to multiply by the derivative of the inside, which is 6x squared. And then multiply negative 4 times 6x squared, I get negative 24x squared. And then move this to the denominator so that I can get a positive exponent. Now you might have to do multiple chain rules. So like right here, I have sine to the 8th power, or you might write it like this, sine of all that to the 8th power. Well, the first thing I need to do is think of this as a function to the 8th power. So I would take 8 times the function to the 7th power, and then multiply by the derivative of the inside. But the derivative is actually sine, the inside is actually sine of that polynomial. So then how do I take the derivative of sine of that polynomial? Well, the derivative of sine of a function is cosine of the function, then times the derivative of the actual function. So then I finally have to take the derivative of this, and that gives me 10x to the 4th minus 7. So I end up with 8 sine to the 7th of this binomial times cosine of this binomial, and then times this other binomial. And so it's a little bit complicated, but it can be done. Okay, so I want you to freeze the video and try to do this one. This actually involves the product rule, but within the product rule, there's 2 cases where you have to do this general power rule. So pause the video and then start back when you think you've got it. Now notice I simplified this as far as possible, and what you'll find interesting here is if you set this equal to 0 and find all of the zeros of this derivative, you'll actually find that there's 5 of them, plus or minus square root of 3, 3 halves, and then this number plus or minus this radical, which is actually 1.6 and negative 0.5. And if you look at the graph, you'll notice that at each one of those points on the graph, you'll notice that you're going to get a horizontal tangent line. And that's because that's where the derivative is 0. Well, that's all I have time for on this lesson, so I'll move on to the next lesson on the next video.